Boca Chica, Texas, the birthplace of every Starship. Here at the Starbase, SpaceX is building and testing its fleet of gigantic rocket prototypes. Their goal? Make a reusable vehicle that will allow humanity to reach and inhabit other worlds. Each ship starts as one stainless steel ring. Although not as light as aluminum or carbon fiber, stainless steel offers other advantages. It was chosen for Starship's primary build material because of its strength and temperature tolerance, which is crucial for achieving full reusability, since a fully reusable spacecraft needs to go through large temperature fluctuations on its way to orbit and back. Rings 9 meters in diameter and about 1.8 meters high are stacked and welded together to build the rocket's hull. Stainless steel is also much cheaper and easier to work with than carbon fiber. This is very important because SpaceX aims to achieve serial production and build hundreds of these ships. These 4 rings are part of the skirt section. This is where the aft dome and thrust puck are located. We'll return to see how the engines are installed there later. Stringers are added to support the massive weight and increase the structural integrity of the rocket. Rings stacked above form a liquid oxygen pressurized tank. Starship will use liquid oxygen and liquid methane for propellant. The common dome separates the liquid oxygen tank from the liquid methane tank above. The methane header tank is connected to the thrust puck with a downcomer, a pipe that supplies the engine with fuel. Liquid methane was chosen because of its many advantages. It's cheaper, easier to produce, has higher performance than other fuels, and can be made on Mars, allowing us to refill and relaunch spacecraft from the surface of the red planet. The methane tank section of the ship ends 4 rings higher with the forward dome. The battery, necessary for the operation of the ship, is located here. From here, rings stacked on top are secured with stringers, and together with the nose cone, make 1,100 cubic meters of usable space that will contain mission payloads in the future, and hopefully, someday, crew. The nose cone of the ship houses COPVs used for RCS. The oxygen header tank is located at the very top of the nose, raising the center mass of the vehicle, which makes it easier to balance the Starship during re-entry. Header tanks contain landing propellant. They're better insulated and separated from main tanks to minimize fuel boil-off and fuel sloshing on re-entry. Another downcomer goes close to the windward side of the ship and connects the header tank with the inner plumbing and engines. Engines propelling this colossal beast are Raptors, full-flow staged combustion engines. The ship will utilize the sea-level variant and vacuum-optimized variant with the nozzle specialized for firing in space. Three gimbalable and throttleable sea-level Raptors are installed in the inner ring, and 3 fixed vacuum Raptors make the outer ring of the engines. Also here, we can find a hydraulic power unit and some more COPVs. On the hull of the ship, we can see data and power cables and pipes used for autogenous pressurization. Flight termination system is installed in case the rocket loses control and needs to be blown up safely. Motor-controlled forward flaps are installed on the nose of the rocket, and they together with the bigger aft flaps on the bottom of the ship, provide the aerodynamic surfaces necessary for the atmospheric re-entry and belly flop maneuver. During that atmospheric re-entry, the ship will require a thermal shield to survive extreme temperatures of up to 1,700 degrees Kelvin, or about 1,400 degrees Celsius. For that purpose, SpaceX will use shielding made out of many hexagonal ceramic tiles. Covering the spacecraft's windward side, thermal tiles are placed on mounting points with the ceramic insulation padding placed in between them and the ship's steel body. With most of the tiles being identical, they are aimed to be easily replaceable, allowing for Starship to be rapidly reusable and easily serviceable. When fully assembled, 50 meters high, Starship makes a truly extraordinary sight, reminiscent of old science fiction rocket designs from the 50s. SpaceX has taken the approach of rapid testing and innovation, and the design is being questioned, changed, and optimized constantly.